So shown here are the truncated, so basically cut off, okay, we've cut off the top of them, cylinder and a truncated cone. Using a pick, indicate whether each of the following statements is true or false. A truncated solid is a solid that has been cut horizontally, vertically, or at an angle. Now, it cannot be cut horizontally. Okay, so that there is false. The base of a cylinder is based on a regular polygon. The base of the cylinder, false as well. Okay. And then an elliptical shape is created by when a cylinder, so an ellipse shape, when the cylinder or the cone is cut at an angle, and that one there is true. Okay. Now, the truncated solid is a solid that has been cut horizontally. Now, at an angle is fine. Vertically, it's going to give you like a rectangle shape if you cut it that way there. And if you cut it straight across the top, it's just going to give you a circle. So Espresso Perfecto, a coffee shop, carries out a survey on its customers by asking them what is their favorite beverage. Below is the information gathered. So 40% of the people said latte, 10% said cappuccino, 25 said espresso, 15 said hot chocolate, and 10 people said Americano. Divide the given circle to represent this information graphically. Note that the data from the latte has already been added. Add color hatching to define the sectors. So how do we go about doing this one? Remember that 100 people were surveyed. Therefore, 100 people is equal to 360 degrees because there are 360 degrees in a circle. So if we divide 100 by 100, that'll give us one person. We divide 360 by 100, that'll give us 3.6. So each person is worth 3.6 degrees of this here. So if we have 10 people, we multiply that by 3.6, and that'll give us 36. And that is for cappuccino and for Americano. Then we multiply 25 by 3.6, because 3.6 is for one person. So if there are 25 people, that'll give us a degree of 90 degrees. And that's for espresso. And then finally, 15 people said hot chocolate. So 15 multiplied by 3.6 will give you 54 degrees. So you've got the latte already. All right. Espresso is 90 degrees. So you could just draw a line straight across here and straight down. Then you're left then with cappuccino. Now you can just get your protractor. All right. Put the crosshairs here in the middle. I'd have to extend this out a wee bit here. So you put the crosshairs here in the middle. You line up that there with your 0. And then you mark out 36 degrees. You join this out to that 36 degrees. And that gives you then that line. Next then, it doesn't matter what order you put them in. All right. But hot chocolate, for example, is 15 people. So this is hot chocolate. That's 54 degrees. So you put your crosshairs here. You line it up with this line you've drawn out here. And you mark then 54. And you draw that line out there. And that gets you the hot chocolate. And then put crosshairs in the center again. Line up the 0 with this line here. You mark off the 90 degrees. Draw this here straight down here. And that gives you espresso. And then cappuccino is what you're left with. Okay. Nice little bit of colour into it as well. It just makes the thing stand out. No harm to put a wee bit of maths here as well to the side, just to show exactly how you figured out the angles. All right. And that's how your question should be finished. Now, a 3D image on the right shows a coffee machine. The elevation, direction of the arrow A. So remember our planes of reference here. Okay. An end elevation, direction of the arrow B. So this, our end view is going to end up over here. Our elevation, so our plan is going to end up down here. So the plan is going to be down here. All right. So project a plan from the given views to show the curve created by the truncated cylinder. Note that the drip tray is offset by 5 mil. The main thing that they'll want to see in this question, okay, and the hardest part is this when we're looking down in a plan at this here, this is going to end up looking like an ellipse. All right? And how we get that there, we get our 3060, and we're going to divide this circle up with our 3060. I'm going to give each of these points a name: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You're going to bring these now straight across. So there is 3, 2 and 4, 1 and 5, 0 and 6, 11 and 7, 10 and 8, and then down at the very bottom then we've got 9 again. Those now, we're going to bring these straight down into our plan. So 9 is going to be along that line somewhere, 10 and 8 is along that line. Now, so we've got we know that the points are along these lines somewhere. Where exactly they are along that line, we're going to draw a line off here at 45 degrees. We're going to bring the point 0 down to here. 0 is along this line. We're going to bring 0 out. That means 0 coming down from here, and that there is your 0 point there. Now you don't, in the exam, you wouldn't have to label these, but I just find that's 1 and 11 is along there. 2 and 10 are along this one. 3 and 9. 4 and 8. 5 and 7. And 6. So 6 is here. 5 and 7. 5 is here. Now, so 2 and 4 are the top ones. Actually, okay, so we follow these down. 6 is here. 5 and 7 are along this line. 5 is out here. 7 here. Next is 4 and 8. 4 and 8. And next is 3 and 9. 3 here, 9 here. And you can start now if you want to draw in that bottom half of that curve. And you're going to do the same at the top, 2 and 10.
Let's go just forward one and shot this.
You can finish off this curve at the top. Then that's the main part of that question. The rest of it now we're just going to draw around the outside. So I'm going to take this down. You can draw this line coming straight back here, and this one here coming straight back from there. And we just have to bring these ends. We're just going to draw the actual coffee beans go in. So that there is just that hopper there. Sorry. That is the hopper here that we're filling in here. We've drawn there. And it says then the trip tray is set in by 5 millimeters. So I presume there's a little 5 millimeters here. And 5 mil here. Now, so it's very important that we dictate where the elevation, plan, and end view go by using our planes of reference, okay, making sure that our plan is in the correct position underneath the elevation. Next then, it's simply dividing the circle into 12 equal parts, bringing it over and bringing it down, and then completing then the plan, all the other sections.